Okay, moving on to the next few problems in our lesson 121 answer review. For this problem, we were still working with fish, and this task had us trying to figure out the probability of catching a green fish. So let's take a look at letter A. Remember that the first number talks about the part, so that's the green, and the probability would be that we would put 2 fish that were green in there. And if I go over here and I subtract 2, that means I have 5 fish that would be yellow or blue. And I can just make a decision about how I want to split those up, and I'm going to say that there's going to be 3 yellow and 2 blue. This next one, I have the 5 is going to represent again the green fish. Over here, I am going to remember that 7 is my total. I'm going to subtract the 5 green fish, and that leaves me the number 2. I'm going to just split that between the yellow and the blue fish for this problem. Letter C is pretty weird. It is impossible because we cannot pull more fish out of a tank than the number of fish we started with. So that is going to be an impossible one. Moving on to the next one, if I want to have the chance, 100% chance of pulling a green fish out of my tank, I'm going to make sure that all of my fish are green. I will have 0 yellow and 0 blue. All right, let's move on to problem 1-57. Joyce has a dad and he packs her lunch, and she's got some yogurt in there. We got 5 yogurts, and our yogurt choices are raspberry, strawberry, blueberry, and vanilla. And he's grabbing one at random, so he's not looking, he's just reaching in. Which flavor is she most likely to have in her lunch today? Well, as I look at this, we've got the number 1 in front of raspberry, 2 in front of strawberry, 1 and 1. So that means that because I have more strawberries, she has a slightly better chance of having strawberry yogurt. What are her chances of finding a vanilla yogurt in her lunch bag? Well, we have 1 vanilla, and there are 5 total. So that means her chance is going to be 1/5, or 20% if you want to rewrite it as a percent. Now I'm going to rearrange my paper a little bit here so that we can take a look at our number line, because what we're going to try to do here with this next problem is we're going to take the events that are listed below, and we are going to put these probabilities on the number line. And I'm going to label them. I'm going to label this A, B, C, D, and E. In the first one, I'm looking at a 1/4% chance, or 1/4 chance that you will be the team member who gets supplies tomorrow. So when I'm looking at this, this number line is kind of messed up a little bit here. So I'm going to, this is where the halfway point is. So I'm going to label that half. And this is 100% because that's where 1 is, and this is where 0% is, okay? So 1/4 is going to be right here, and I'm going to put the letter A here. I'm also going to put 1/4. So that is the answer for that one. A 25% chance of snow tomorrow. Ooh, let's hope not. But 25% is the same as or equivalent to 1/4. So I'm going to put this up above. It's going to be letter B and 25%, because that is right smack dab in the middle between 0% and 1/2. 8/10 probability of eating vegetables with dinner. Now let's see if we can rewrite 8/10 as a fraction. Sometimes it's easier for me to think if I'm looking at something on a fraction, how I can compare that on a number line a little bit better. I can use my giant 1 and I can change 8/10 into 80/100. So this is going to be where it's a little bit more fun. This is about 75% here. So I'm going to go a little bit more, and I'm going to say that this is letter C, and I'm going to put 8/10 underneath it. So that's where that one goes. Letter D is a blue marble. I have remembered or memorized some of my benchmark fractions, but in order for you to solve this, you could do 5 divided by 8. And we know that we can do some wonderful math here, and we end up with 48, and we can keep going. 2 8s go into 20, and we can keep going. This would make 4, bring down another 0. 8 goes into 45 times, so this would become the decimal 625 thousandths. That's a little bit more than 1/2. And so we could just go ahead and we can pretend that this one right here is 0. We'll just call it 5/8 because that's what it was given to us in the problem, and we'll call that letter D right here. So that's where that one goes. And look at that, we have this little teeny number line mark there, and a 1/100th% probability, 1/100th. This would be written as a fraction, 1/100. And so that's pretty small. And that's where this one's going to go right here. And that would be letter E. And remember, we're kind of, when we don't have a number line that is exactly written out and measured out completely accurately for us, we're kind of eyeballing that. So that is that problem. I'm going to move on to the last one. Now, this is where we are trying to decide if it's theoretical or experimental. And so theoretical is kind of thinking about it. And this first one, the chance of getting tails when flipping a coin is 1 out of 2. And this is, I didn't say I was doing anything. This is something I am thinking about. So this is theoretical. I flipped a coin. So I'm actually doing something. I'm doing an experiment. So this is experimental. My mom packed my lunch 3 of the past 5 days. So the probability of my mom packing my lunch is 3/5. And since we're working off of actual occurring events, we're going to go ahead and call that experimental. The chance of winning the state lottery is 1 in 98 million. And this is, again, I'm not talking about buying tickets or anything that I'm doing. This is talking about something that is going to be all in somebody's processing in their mind. So we're going to call this theoretical. Based on mathematical models, so that's using what we have, what we're studying, not anything we're doing. So this is theoretical too, theoretical. And then the last one, Lena got 3 hits in her last 7 times at bats. So her chance of getting a hit is 3/7. Because Lena is actively doing something, this is considered experimental. All right, so that's it for our review of our answers for our first lesson in the second book of our 6th grade math time together.